Today we're going over section 1.4, which is powers of positive rational exponents. So we'll just quickly review our exponents law. So we have product of powers. A to the power of m times a to the n is the same as a to m plus n. We also have power of a power, so a to m to the power of n is the same as a to the power of m times n. We also have power of a quotient, so if we have a over b in brackets to the power of m, that's a to m over b to the m. And our value in our denominator cannot equal 0 because we cannot divide by 0. We also have quotient of powers, which is a to m divided by a to n. It's the same as a to m minus n. We also have power with a 0 exponent. Any value to the power of 0 is 1. We also have powers with a negative exponent. So if we have a to negative n, that's the same as 1 over our a value to the power of n. So it takes the reciprocal of it, and then it does to the power of our n value. So we do have a new rule that we will be going over, which is powers of rational exponents for numerator of 1. So if we have a to 1 over n, that's going to be our nth root of a. So example, rate each power as a radical and then evaluate the radical. So because we have 1/2 here, that means we have the square root of 25. Now, when we have anything that's just a 2, which is square root, we usually don't even bother with that 2 in front. You don't have a number in front, it's assumed it's that 2 value that came from here. Square root of 25 is 5. Okay, this one, we have a 5 here, so that would be the 5th root of negative 32, which is negative 2. This next one, we've got 1/3, so it's going to be the cube root of 64 over 27. Now the cube root of 64 is 4. Cube root of 27 is 3. Next example, write each entire or mixed radical as a power with a rational exponent. So we've got the 4th root of 5.8. We want to change this into a number of an exponent. So we have 5.8 to the power of 1 over 4, because when we have a value here, we just put 1 up top and divide by 4. Next, we have a cube root of 20 over 9, so that would be 20 over 9 to the power of 1/3. Next one, the 2 stays in front, and then we have 5 times 1 over 3. Alternatively, we could change it into a full or an entire radical by moving the 2 inside, so that would be the cube root of 2 cubed times 5, which is the cube root, 2 cubed is 8. So that would be the cube root of 40, which would be 40 to 1 over 3. Now this is probably the preferred one because this is more simplified than this. Okay, next, powers with a positive rational exponent. So we have a to the power of m over n. That's the same as the root of n of a to the power of m. For example, write each power as a radical, then evaluate the radical if possible. So what's in our denominator will be in front of our root. So we have 3 here. Then inside, we have negative 8 to the power of 2. Now, negative 8 squared is 64. Cube root of 64 would be 4. Next one, we have got 1 over 9 to the 302, so therefore it's a square root of 1 over 9 cubed. So that'd be the square root of now, in this case, I could fully expand this, but I also know 1 over 9 cubed is the same as 1 over 9 times 1 over 9 times 1 over 9. Now we have 2 of these, so we can actually move 1 in front. There, so we've got 1 over 9. So that's where these 2 went. Root of 1 over 9. Now we have 100 to the power of 2.5. Whenever we have a decimal, we want to change it to a fraction. So we have 100 to the power of 5 over 2 would give us 2 over 5. So that'd be the square root of 100 to the power of 5. We can do a similar thing to what we did here because we know that this is the same as 100 times 100 times 100 times 100 times 100. So we've got 2 100s there, so we can bring 100 in front. We've got another 2 100s here, so we can bring another 100 in front. And then we've got the root of 100. Now 100 times 100 is 10,000. Times the root of 100, which is 10. So we have 100,000. Practice stuff for this section is page 41. Numbers 4 to 9, 11, 12, and 14.